In today's lesson, you will learn how to sketch the graphs of the form ax plus b over cx plus d and ax squared plus bx plus c over dx squared plus ex plus f. For this first question, I'm going to demonstrate how to sketch the graph of a rational function. So we have y is equal to 3x minus 2 over x plus 2. The first step is to find where the graph crosses the axes. So if we substitute x equals 0 into this function, this leaves us with a value for y of minus 1. So we can plot that on our graph. If we substitute y equal to 0 into the equation, we will work out where the graph crosses the x-axis. If we rearrange this function, this leaves us with x being equal to 2/3. So the graph crosses the axis at these 2 points. As we have a rational function, we need to find the values where this function is undefined. In this case, a rational number cannot have a denominator of 0, which means x plus 2 cannot be equal to 0, and therefore x is not equal to minus 2. Now this means we have an asymptote, which means the graph will approach this line but it won't cross it. And we show an asymptote with a dashed line, so the function is not defined along this line. Now we have the asymptote, we need to work out what is happening with the graph either side of this line. So we're going to approach the minus 2 here from the right hand side and from the left hand side to decide what is happening with that graph. So the idea is that if we choose a value of x that is very close to minus 2 and substitute it into our function, we'll work out whether the graph is approaching positive infinity or negative infinity. So just to the right hand side of minus 2 then, if we choose x to be minus 1.99, substitute that into our function, that gives us a value of minus 797, which is telling us that the graph is approaching negative infinity from the right hand side. And then if we choose a number that is just to the left hand side of that line, so the minus 2.01, that gives us 803. So that is approaching from the left hand side positive infinity. So we sort of have this rough shape of what the graph should look like at this point. So the next step is to see what's happening as x gets very, very large towards positive infinity and also towards minus infinity. So if we substitute in now a very large number for x, so we've got 1000 there, that gives us 2.99, very small number. So from here, as x is getting very, very large, it's approaching infinity, then y is kind of tending towards 3. If we do the same thing but a very large negative number, so minus 1000, this gives us 3.01. So as x is approaching minus infinity, then y is tending to 3. So this is showing us that y is approaching 3, but it's not actually reaching it, and therefore y equals 3 is another asymptote. And so we can draw that onto our graph. And we can then plot these points. So we have from the positive side, so when x is tending to positive infinity, very large number, y is equal to 3 or tending towards 3. There we go, from below, because we have 2.99. And from the other point here, we have that when we have minus 1000 for x, so x is tending to negative infinity, then y is tending to 3, but it's from above this time because we have 3.01 for the value of y. So that would be from this position here. Now from here, we just kind of fill in those lines. We're drawing a rough sketch. So if we join these up, and on the other side, this is what our function should look like. Okay, so a summary then of sketching a graph of a rational function. So this is for your notebooks. First step is to find the x and y intercepts. Then you find the x values that make the denominator equal to 0. So this will tell you where the x asymptotes are. And then we check either side of the x asymptotes to find the direction of the graph. And the final step is to substitute in large values of x to find the y asymptote. and then we check large positive and negative x values to find the direction of the graph. Okay, so there is an alternative way of finding the y-asymptote without substitution, and let's take a look at that method now. So we first of all find an equivalent fraction of the one that we are given in the question, so the 3x minus 2 over x plus 2. And we do that by dividing by x. Now we divide by x there because the leading term of this fraction has a power of 1. So we are divided by x to the power 1. So we are dividing both the numerator and denominator by that value of x. Now, if we were to split this up, we would end up with 3x over x, which is just 3, and then the second term minus 2 over x for the numerator. And the denominator, we would end up with x divided by x, which is just 1, and then the plus 2 over x for the final part there. And then from here, we just see what's happening as x tends to infinity. So as x gets very, very big, then the 2 over x in the equation there will tend to 0. Okay, 2 over a very, very big number would be very, very small. And so as x is tending to infinity, then y must be tending to 3 take away 0. So we've substituted in there where we see 2 over x in this equation, we've substituted in 0. So we have 3 take away 0 down at the bottom over 1 plus 0, which is just 3. So this is telling us where. Okay, so another example then. So we're going to sketch the graph of this rational function 2x plus 6 over x minus 3. So first of all, the intercepts. So we have when x is equal to 0, y is equal to minus 2. Y is equal to 0, we have x is equal to minus 3. Secondly, we're going to find the x asymptote. So this is where the value for the denominator that is the function will not be defined. So this is x is equal to 3. We draw in the asymptote and we work out what's happening either side of this line. So we choose a number very close to 3 from the left and from the right hand side. So 2.99 and 3.01 would be fine here. And we can work out that on the left hand side it's approaching infinity, negative infinity, and from the right hand side it's approaching positive infinity. Then the y asymptote, so we have y is equal to 2. Now that comes from if we divide the numerator and denominator by x, we would have 2x plus 6 over x, and then x minus 3 over x, and this would leave us with, so 2x over x would just be 2, and then you'd be left with 6 over x for the second part, and then the denominator we have x divided by x, which is 1, and then minus 3 over x for the second part. And then if we take either of those two parts there, so as x tends to infinity, both 6 over x and 3 over x will tend to 0. And so as we look at this whole function, this means that as x tends to infinity, then y would be tending to 2 plus 0 and 1 minus 0, which is just 2, which is here. And so the final step, just get rid of that part there, is just to check the large values of x to see what's happening either side of this asymptote. And so we can substitute in x being minus 1000, and this would be below the asymptote on the right hand side, and we would check with x being equal to 1000, and that would be above. And then we can join these up and we have our graph. Okay, now we're going to take a look at another example here. This time we have a linear factor on the top and a quadratic factor underneath for the rational function. So we do exactly the same process again. So we have intercepts first of all, so we substitute in x equal to 0, and that would give us minus 3 over 2, and y equal to 0, that would give us x equal to minus 3. And then we can find the x asymptote, so we're looking at the denominator, that's x equals to 1 and minus 4. So now we've got two lines that this graph is defined by. Check either side of these. So this time, if you are looking at the left asymptote, so you need to substitute in x equal to minus 4.01 and x being minus 3.99 to see what's happening there. And for the other one, x is equal to 0.99, so that's just to the left and very slightly to the right, so 1.01. And if you substitute these in, you should be able to work out which side of the line that is the graph is going to be defined and where it's coming from. And so we have these arrows here just to indicate where the graph is going to be drawn in from. And then remove those bits of writing. Okay, so the next step is to find the y asymptote. So this time we use the same process as we did last time, only now because the denominator is a quadratic, we would be dividing each term by x squared rather than x. So the first step here would be to multiply out the denominator, so 2x plus 6 over x squared plus 3x minus 4. So if each term is, we divide by x squared, so you've got 2x divided by x squared, so that would give us 2 over x, and 6 divided by x squared would be 6 over x squared, and underneath x squared over x squared is 1, and the second term there, 3x over x squared is 3 over x, and final term 4 over x squared. Now the same principle works here as before, so if we still look at what's happening to this function as x is tending to infinity, it doesn't matter whether we've got x as the denominator or x squared, they will still tend to 0, it's just the x squared gets there a bit faster. So all of those terms, 2 over x and 6 over x squared, 3 over x and the 4 over x squared, they all tend to infinity to 0. So this is telling us if we were to substitute those in, we would have the numerator, so y would be tending to the 2 over x is 0, 6 over x squared 0, the 1 underneath, and then plus 0 minus 0, so that would indeed just be 0. So y is 0 is the asymptote here. And then we're checking either side again, so what's happening as x is very large and very small, minus 1,000 and say plus 1,000. So if we substitute that in, we can work out that the function will be below the asymptote on the left hand side and above on the right. Then we can start to join these up. So the first bit is nice and easy. Notice in that middle group there, it does cross the asymptote, and it can do that. And then we've got that final leg there in that last section. Okay, so just bear that in mind. Although the function is not defined, sometimes it can cross an asymptote. Okay, you might like to have a go at this one on your own before going through the answers, so pause the PowerPoint now if you'd like to do that, and then we'll quickly run through the answers. So the setup for this is exactly the same as the previous examples that we've gone through. Okay, so take a look at the intercepts first of all. So we have x is equal to 0, then y would be equal to 2, and when y is equal to 0 we have x is minus 4 and 1. Then the x asymptote, so we're looking at the denominator of this function first of all, so we have x is equal to minus 1 and x is equal to 2, so we can draw those on. Then we're going to choose points either side of those two asymptotes, so we can substitute in numbers that are very close to minus 1 on the left hand side and right hand side, very close to 2 on the left and the right, and we should find that the graph is on the left hand side from negative infinity for -1, and on the right hand side, so from positive infinity there, and you can see what the graph should look like for the second one. And then we find the y asymptote by doing exactly the same thing as we did last time on that very last example. So if we multiply out the functions at the top, that would be x squared plus 3x minus 4 all over x squared minus x minus 2. And if we divide all of those terms by x squared, that would leave us with 1, 3 over x, 4 over x squared, and 1, 1 over x, and minus 2 over x squared. And if we look at what is happening to that function as x tends to infinity, then y would be tending to 1 over 1, which is just 1. So the asymptote here is y is equal to 1. And then if we look at the function again, as x is very large positively, so if we substitute in x is 1000 and negatively it's a minus 1000, then we will see that the graph approaches from both these two sides. And joining these up, and we can use the graph now to work out where the graph crosses the asymptote when y is equal to 1 by solving this. So if we substitute y is 1 into this function and then rearrange, we would work out that x is equal to a half. Okay, so we've got another example here, x squared minus 9 over x minus 1 all squared. And we approach this in exactly the same way. So we find the intercepts first of all and plot those. And then we look for the x asymptote, so looking at that denominator again. So we've got x is equal to 1. And we check either side. Now in this case, when we substitute in a number very close to 1 on the left and the right hand side, the graph is approaching from the same direction here. And then when we find the y asymptote, so very similar to the last example, so if we multiply out the denominator of that original function that we're trying to graph and then divide each term by x squared, we should get to y being equal to 1. Now this is the important step because we're checking the large values of x. It looks as though we might know what this looks like, but it's still important to check what side of the y equals 1 asymptote the graph will be approaching. So from the left hand side, when we substitute in minus 1000, that would be just underneath the asymptote. But when we are looking at x equal to 1000, that's above. So that's important to just realise this because again, when we draw this graph, it's going to cut through that asymptote. Now, let's see at what point it cuts through the asymptote on the right hand side there. So if we substitute it y equal to 1 into this function and rearrange this, that will leave us with x being equal to 5. And now we can plot this. So it's really important that we check that and we work out any points that the function does cross the asymptote as well. Okay, so another example with a quadratic numerator and denominator. Same setup again. So if we start with the intercept, so when x is 0 and when y is 0, and plot these points, then we can work out where the x asymptotes are. So we're looking at the denominator. It's not in a factorised form, but if you type that into your calculator, it will give you complex roots, which means there are no solutions to this, and therefore there is no x asymptote. To find the y asymptote, we'd need to multiply out the numerator here so that we have the expanded form for the quadratic, and then divide each term by x squared. And this gives us an asymptote of y is equal to 2. And I'm going to check either side of this again. So when x is 1000 and when x is minus 1000, so it approaches from above on the left and below on the right. And so We know we're going to have to cross the asymptote at some point here, so let's try and solve this. So when y is equal to 2, if we substitute this in and rearrange, this gives us the value of x being minus 2. And so if we plot this, this is what this function looks like. Very, very interesting to see this type of curve. Okay, please have a go at completing question 1 only on exercise 4b and 4c, and you'll find those on pages 86 and 90.